Hi everybody, we will start solving exercise number 7. So we have a function f of x minus 1 plus 4 over x minus 2, and c is the representative curve of function f. We will solve in this lecture part 1, 2, 3. Part 1 determine the domain of definition. Part 2 show that x equals 2 is an asymptote. And part 3 is to find the limits at minus and plus infinity. Part 4 and part 5 will be a homework. So before starting, let me first remark that you can use one of these two expressions of the function f of x. So either you use x minus 1 plus 4 over x minus 2, or just take a common denominator and reduce or simplify the numerator expression, and you can rewrite the function f of x in the form x squared plus 3x plus 6 over x minus 2. So you can use either one of these two expressions. So first of all, the part 1 to determine the domain of definition of f. So f is defined when x minus 2 is different from 0, that is, x is different from 2, and then the interval form is that x should be between minus infinity 2 or 2 plus infinity. Question 2 show that the straight line of equation x equals 2 is an asymptote. So x equals 2 to be an asymptote, then this straight line should be a vertical asymptote. Why? Because the vertical asymptotes has an equation x equals to some constant. So in other words, the question is to find the limits at 2 plus and 2 minus, and the answer should be infinity, and then you can deduce that x equals 2 is a vertical asymptote. So first of all, I will find the limit at 2 minus. So I will use the first expression of f of x, or the original expression. You can use also the second expression. So I will replace x by 2, then you will have 2 minus 1 plus 4 over 0 minus, because you are taking the limit at 2 minus, and then you will have 1 minus infinity. Why? Because plus 4 over 0 minus is minus infinity, and 2 minus 1 is 1, so 1 minus infinity, and the answer should be minus infinity. Similarly, the limit at 2 plus, you will get the answer plus infinity, and then you can deduce that the line of equation x equals 2 is a vertical asymptote. Also, the same answer, you will get the same answer if you use the second expression of the function f. So you will have some constant over 0 minus and some constant over 0 plus. Now moving to part 3, determine the limits at minus infinity and plus infinity. Okay, I will use the first expression of f. If you want to use the second expression of f, you just need to take the highest power in the numerator and the highest power of in the denominator, which is x squared over x. Simplify this expression, the answer is x, then limit at plus infinity of x is plus infinity, limit at minus infinity of x is minus infinity, but I will use the first expression. So I want to take the limit at plus infinity. I replace x by plus infinity, and you will get plus infinity minus 1 plus 4 over plus infinity. Now plus 4 over plus infinity is 0, because any number over infinity is 0. Then the answer is plus infinity plus 0, which is plus infinity. Similarly, the limit at minus infinity will get the answer minus infinity. Finally, please do homework part 4 and part 5.